Thank you, Alex, and thank you, LF Energy, for having us here today as your keynote panel. We're really excited to be here. And so this panel will be covering expanding the OpenSynth ecosystem, open source data and AI for power systems modeling. I'm Amber Woodward. I'm the International Public Affairs Manager for Centre for Net Zero. Centre for Net Zero is an open, independent research institute that was founded by the Octopus Energy Group in about 2021. And we are interested in forecasting the future of energy demand. I'm here today with a great lineup of panelists who I'll introduce before we kick off. So I'll start from Pedro. Pedro Vergara is an associate professor at Delft University of Technology, leading a research team that exploits AI and optimization tools to solve challenges related to planning and operation of city-level electricity infrastructure. So thanks for joining us, Pedro.
Thank you for the invitation.
Next, we have Sebastien Lepy. Sebastien is the general manager of Cresym, a not-for-profit research association gathering the energy industry and research players. He's been active in the energy sector for more than 20 years at Total Energies, EDF, RTE, and for 10 years at ENTSO-E, where he set the foundations for the 10-year network development plan and adequacy forecasts, and graduated from the École Centrale in Paris and University in Stuttgart in process engineering. So thanks, Sebastien, for joining us.
Thanks to be here.
And then finally, next to me here, we have François Mirallès. François is from Hydro-Québec at the research centre there and has been since 2007. He earned his PhD in electrical engineering from the École Polytechnique in Montreal and specialises in AI applications within the electrical industry and oversees Hydro-Québec's contribution to grid foundation models. So thanks for joining us, François.
Hi, I'm glad to be here. Thank you.
Fantastic. So we've got about 40 minutes-ish, I think, for this panel. So we'll start with a few questions that I'll pose to the panelists, and then hopefully for the final 5 to 10 minutes, we can open up for Q&A from the floor. So get thinking about any questions you might have for the lineup here. But before I do get into questions, I wanted to give a little bit of a background to OpenSynth. So at Centre for Net Zero, we're really focused on the demand side of the energy transition. There's been a huge amount of focus on decarbonising the supply side of the energy sector, but perhaps less of a focus on the demand side. And as we'll be moving towards an era of a huge amount of load growth, we should be turning our focus towards that, thinking both about consumers who will be installing new technologies in their homes, like heat pumps and EVs, but as well as the commercial and industrial sector, where things like data centers will add a huge amount of load to the network. And with this transition towards a decentralized, decarbonized, and digitalized energy sector, there's a huge potential to make more of the data that we'll have access to, particularly from those consumer devices in people's homes. But actually, we found that data is largely not available and difficult to get access to. So we're really interested in democratizing access to demand-side data to benefit consumers and help inform decision-making, ultimately lowering costs for everyone. But often, privacy prevents this. So what we did was develop a model called Faraday, using generative AI to model energy consumption and producing synthetic smart meter data, demand-side data, improving access whilst respecting privacy. And then we've collaborated with the Linux Foundation to launch OpenSynth, which is an open data community which was initially focused on just demand data, but has since expanded to cover all types of data, model algorithms, and evaluation frameworks that can help train AI models, but also perhaps AI generated as well. So Pedro, you've been with us basically since the beginning. So I thought I'd start with you and ask a bit about your experiences of developing algorithms for smart meter data, and why current algorithms for AI-generated data don't quite work for smart meter data.
Yes. Yes, I can highlight that during our research, we focus much on the planning and operation of the electricity infrastructure, so medium, high voltage, and low voltage. The lack of data is the first problem that we face when we try to develop new ways to optimize the planning and operation of this infrastructure. So when I found out about OpenSynth, it was a match into the needs that we had also as our researchers, and opened many possibilities of addressing challenges when it comes to the use of generative AI for this particular initial task of generating data. So since then, we are focusing on developing many generative AI models, focusing on exploiting the particular characteristics of these algorithms, right, applied to our needs in the energy sector. And that comes with the dimensions that we discussed in the OpenSynth project related to fidelity, right, how these algorithms are capable of generating synthetic data that closely match the statistical properties of the original data. So we are not copying the data, we're just learning the statistics behind the data, so we can then make use of this data for planning and operation, many applications in the energy sector. And the other two dimensions, of course, important, fidelity, utility related to what are the particular needs that we need for use of this data, and of course, privacy, right? We are generating synthetic data, but still we need to make sure that this data doesn't release the privacies of the original sources of the data. So we are focusing on addressing many of the challenges related to these algorithms that require less demanding computational infrastructure, so it's also facilitate the access for industry partners, but also algorithms that are not commercially available, right? So this is what we are doing in the light, or let's say in the context of the OpenSynth project.
Great, thank you, Pedro. And you've kind of talked a little bit there about what the data could be used for. So I'm going to turn now to François, because you've been thinking about how OpenSynth might complement or enable some of the work you've been thinking about related to foundation models, and particularly Grid FM and other Linux Foundation Energy projects.
Yes, exactly. So I'm going to start by talking a little bit about what is Grid FM product. So we are working to build what we call a foundation model for the grid. And at the core of this concept, it's building an AI representation that is aware of how energy flow through a network. So we are using the power flow problem as a proxy task, on which we pre-train the AI representation on power flow solutions. Once we are able to do proper data imputation on this set of solutions, so we have this AI representation that can provide a stronger learning signal in order to solve all kinds of downstream tasks that are related to power flow. In order to push forward the concept, we now generate data with a first module that is called the data kit that was contributed by a team from IBM, which is here today. They are going to do a presentation, I think, later this morning. And also there will be a demo. So with the data kit, we are generating all kinds of examples used to train the AI algorithm. So we do variations of the load, of the topology, but essentially we are solving a math problem at first. So this brings us to a certain level of ability of this AI representation. But then I think with OpenSynth, we can add another stage of training this representation. with data that represents reality more closely. So I think OpenSynth now can generate some active power. And certainly, we should add the ability to also generate reactive power. And the ambition is to be able to solve power flow for any network on the planet. Then, maybe I anticipate on the other question that you will ask later in the panel, so I don't want to take too much time. I don't want to, because we prepared the question, I shouldn't say that. But so the goal here, we are at the early stages of developing Grid FM, and the next step is to create this bridge between OpenSynth and Grid FM and see how far we can go. Yes.
Thank you. And I think it's okay to prepare the questions.
That's it for the first question.
Yeah, great. Thanks, François. So you've spoken a little bit about the data that we already have in OpenSynth and how that could be used to help train Grid FM, but also acknowledge that there's maybe more that we could add. And so that's sort of why this summer we've expanded the scope of OpenSynth, so we're not just focused on demand data, but also a place for all types of grid data that could be used for training AI models, demand, grid topology, and supply. And Sebastien, you've been sort of leading the charge there, working with RTE to donate the RTE 7000 grid topology dataset. So could you talk a little bit about what that is, and how you saw the synergies between your work at Cresym and OpenSynth?
Yes. So it's a bit of a paradox because here we'll be speaking about real data. And it's actually the point of having them in OpenSynth as a kind of a new chapter aside Faraday. So what my colleagues developed, so nice AI tool, cool AI tools, well, they must be eventually very useful and very practical tools for, well, every player in the game, especially grid operators. And so we tend to and especially RTE, who proposed this RTE 7K dataset, but I know there are some other operators also thinking about contributing. The idea is really to start with the very practical issues that, well, operators, but also every market player face with data. So we spoke about privacy, we spoke about security. There is also a very basic thing, which is the consistency of data. If you want to do something powerful, you may have very different sources, totally inconsistent, that you have to reconcile, and well, you may not be totally at ease with that. Another thing is the data quality, and it may stem from very different problems. So it may just be the creation of the data. So you may have mismeasurements, or you can also misinterpret the data you receive, misunderstand, or maybe twists everywhere. So the idea is that, okay, how do we cope with that? And especially there is a high pressure on system operators to provide data. They are the nexus of the power system. So everyone, okay, you have them, so please give them to us. And actually, there is a lot of problems for these system operators. First, they may have the data, but only in theory. In practice, it's a real challenge to gather them and to make them consistently available, etc., etc., and also to guarantee that it is reliable enough. Second, sometimes they're just not allowed to release the data, so it's privacy, confidentiality issues of especially market players' data. So the point, and I think it was maybe we can have also some RT representative commenting on that. The idea was, okay, we just give what we have as it is, and you can play with it. But we don't try to reconcile all these complexities of, well, how can I handle the confidentiality of my every connectee to my grid? And actually, it can be very powerful, because if everybody does that, so I mean everybody owning some data, making the data available to others openly, that could be a very nice collaboration where everybody puts their little brick, and eventually we have nice walls that could be built. We can also see what is the reality of data at every place, how we can cope with that, what solutions we can also propose to help people understand these data for the purpose they have, also understand the purposes of everyone, and maybe address the most important one before others. So just sharing what you have instead of trying solving the problems of others can already be very fruitful, we believe. And that's the point of RTE7K, just to come back to it, and to Digit. So Digit is the umbrella in OpenSynth, this chapter, where we would like to welcome real data set, especially grid data sets, because they are the backbone of our energy systems. We can then hook many other data sets, be they real or be they synthetic. And that's the idea. If we can disclose possibly some real data here, maybe there, we can only have the possibility to hook synthetic data. And we can have different perspective on, for instance, yes, smart meter data attached to that location, or from one I would say maybe a very pessimistic perspective, so you twist a little bit the statistics to have them, or another way. So there is many ways you can have it. You have many dimensions you may want to explore. And our idea is that by providing such real data sets where you can hook synthetic data, we can just generate maybe not digital twins really, because that won't be the real thing, but at least synthetic twins of the power systems that would be just as useful and practical.
Yeah, fantastic. Thank you. And I think you've touched on a really interesting point there about the way that real and synthetic data can be used together to generate useful outputs. And you also sort of mentioned again the challenges around privacy, and Pedro, you've sort of worked on this as well. I wonder if there's anything more you'd like to say about how you can encourage perhaps grid operators or other researchers to feel confident using synthetic data as either a tool in the arsenal to use alongside other data types like real grid topologies, or as a way to still make progress whilst real data is difficult to access.
Yes, that's a really good question. So this, any AI development, of course, requires as a first step availability of data. Data needs to be there, right? So if we want to push innovation, developments, create connections between companies, industries, we need access to data as a first step. And I want to build on the idea of that Sebastien mentioned. So this synthetic data, synthetic twins. So what they're going to allow us is to start and kick off these developments that are needed. So small enterprises, they will have access to this synthetic data, develop their own algorithms, right? And for those that privacy is more important, you can still make use of the tools that are developed with synthetic data, but later you can fine-tune it with your own data. So you save resources by working in a collaborative way, which is, in general, the spirit of the Linux Foundation Energy, right? So it's a perfect idea that will enable for all of us to sort of bring a little bit into the table, enable developments, but then we all get the benefit later with updating these algorithms with your own data. So privacy is also respected.
Yeah, thank you. Thanks. And François, you've spoken a little bit about what other types of data you might like to see in OpenSynth, but if you had a magic wand and could, add additional types of data to help with training Grid FM or other foundation models for the energy sector, what would you like to see? I
would say additional data, certainly, but maybe additional features. And so something you said, Sebastien, synthetic twin, and I formulate it also as a synthetic grid operation. Because if you add a bit more granularity in terms of the controllers, changing different settings on your network, then you can activate these controllers in order to create a given diversity in the data set you produce. and you want to approximate, of course, the real grid. And the hope is that if you train on this data, then you'll be able to apply this AI representation to solve a real-world problem. So the question is, how far can we go in adding this realism, and yet make it useful for different companies, because different companies have different ways to operate their grid. So this question remains to be answered. So I wonder what is the common ground we can have around this axis. Then after that, we talk a lot about privacy. And this comes from the privacy of smart meter data, because we are dealing with the privacy of individuals. But then if we start training the OpenSynth on, let's say, data of a substation, what we are wondering now, and it's something we talked about in the Grid FM workshop just before the Lepy event, and there is this term, let's say, cybersecurity preserving synthetic data. So I think there's more work to be done in order to understand what kind of techniques should we use, or what kind of framework should we work in order to be able to train OpenSynth on real, let's say, substation data and ensure, let's say, cybersecurity requirements. Because in the end, maybe what we need to hide is not just the actual values of, let's say, the power or reactive power, but maybe some statistics, actually. Statistics about a specific power substation that can reveal, let's say, confidential information, actually, about the network. So there is some work to be done in, I think, understanding the cybersecurity implications of sharing this data, and how do we adapt our cybersecurity practice to this, let's say, reality of sharing more electrical data. So here we're talking about moving organizations. So there is lots of presentation, documentation to produce in order to advance the thinking. Not every company is at the same level. So I would say kudos to RT for releasing this data set of real topologies. And I think you are really leading the field. And yes, I think it's a lead to follow. That's my personal belief. But then there are many people to convince.
Well, that's a really good segue to Sebastien. You've have DGIT, which is a tool for generating these kind of grid topologies that RT have released. And I think you're working with utilities to try and release more data sets like the RTE one, so a bit of a call to action from everyone in the room here who's at a TSO. But do you want to talk a little bit more about how DGIT works and what you're doing working with utilities to try and release more data sets like that?
Well, actually, it's just a work in progress. So and it's good that we have it that way. So again, we're having a conversation with all parties that are interested so that we can make it what would be needed out of it. So the first thing is to possibly generate some, so first, no, there is an earlier thing that we came to. This is a very tricky data set. So it's real data, so it's the true thing, but it's very complex to actually interpret and not to be just fooled by the way it is presented. But it's the easiest way for an operator to provide it, in that case RTE. And thank you, by the way, François, for explaining what it is. So yes, it's the topology of the grid over 3 years, every 5 minutes. So you have very detailed node breaker level, the topology of the French grid, so that that's about 7,000 nodes. but yeah, the position of the breakers, the way they are coded, is not always the same way from one time step to the other. So if you want to keep track of it, it might just be misleading. But that's what real life is. And sometimes you also have some changes in the definitions from, well, I don't know, every 6 months, maybe there is an update in the grid consistency and and you have to cope with that. And it's terabytes of data. And so we have to first make sure that we have a community that is aware of such complexity. And we'd like to launch a challenge early 2026 to possibly not go to the immediate step we have thought about, which is how to build such other data sets and to play with it and to move forward. But first, let's understand that and find the right ways to help people not to be fooled by the complexity that is inherent to such data. So that's the first thing we have. Next step would be to also see what are the needs of the participants in terms of, yes, complementary data that you would need to actually be able to have fun with the data set. And if we have also to let it just free or to kind of streamline or provide methodologies to develop different kind of interrelated data sets, possibly synthetic data. Do we have, for instance, to provide an idea of the statistics that your whatever kind of data will have to match to be representative enough of, I don't know, the summertime, the wintertime, the France or the Netherlands, or I don't know, how you can actually also transpose the situation that we have here for one place to another. So there is, and here we may need to collect also data from other places and see what they have in common. I agree with what you said, François. We have to understand that the differences between the operation here, there may be different, and maybe we can find patterns. And maybe for that, if we could have data provided by operators from different places, we could have also developed the tool. We could also develop the tools to try to get a higher level picture about what is common, what is different, and it may be just rightfully so. So these are the different steps. So first, understand it, and probably the challenge will be about it in 3-4 months' time. The idea is to define it first. And so if you want to also take part of the conversation, come to us. I think my 2 colleagues, I haven't spotted there in the room, but Gitu especially will be happy to discuss that. No, she's not with us in the morning. And also the next step, yes, is to provide tools to help other operators to provide such backbone data. Next step is to help other people to complement such backbones with the real data sets, synthetic data sets, but it could be nicely sorted out so that people would use them with good confidence of what they would be manipulating with no risk of mistakes. So that's about the ideas we have, but again, we're open to suggestions on this one.
Yes, and I would agree the same on the demand side data that we have as part of OpenSynth as well. We have model algorithms as part of OpenSynth. We have Faraday, the model that we've developed at Centre for Net Zero, Energy Diff from Delft University, and we also have data sets as outputs from those models too. But we're really interested in how people in this room, elsewhere, are using that data and those models to try and understand, does it really work in different contexts? If you're training the model on data from different regions, are you still getting realistic outputs? And that's something that we're very interested in getting your guys' collaboration on. We're thinking about different regions that we could train Faraday on, for example. And Pedro, I wonder if you want to say something about the models that you've been developing, whether you're training it on data from different regions or whether you're looking beyond household, substation level, and other data types on the demand side.
Yes. Yeah, that's very important, validating the models at a more larger scale, I would say. And for that, I think that we do need to thank the AI lab and Power Grid model team from Alliander. So we are collaborating very closely with them. And what we do is that in this particular case, we took Energy Diff, which was the model that we specialize on time series energy generation data, for generating a large database of synthetic data at the medium voltage level. So we are working together with the Alliander team to make this data available, also to be part of the OpenSynth sort of database of data and algorithms. So collecting data from different type of users, customers, commercial, industrial. Residential is a little bit more complicated because of regulation, but at least we can start with the ones that are, let's say, easy to release. When it comes this is more on time series data generation, but I do want to touch upon the point of Sebastien and François when it comes to this multimodal data. So we are so far focusing on active power data, but François is calling for other type of data, reactive power, together with weather data. These are data with different characteristics or discrete. It's not only continuous data. So these, of course, are features that many algorithms that are currently available cannot manage. And this is the part in which we, universities, play the role on developing the algorithms that will ensure that the synthetic data generation can manage this multimodal data, ensuring the quality that is needed for the particular applications in the energy sector.
Yes, and I think you're collaborating quite well with industry. You talked about Alliander there. You're partnering really closely with them. What ways do you see industry collaborating perhaps more with academia? Are there particular areas that you see academia having particular strengths in that can support industry and vice versa?
Yes, it's precisely that. So we have the people that are trained, the knowledge to develop these AI algorithms that are not commercially available, and that might solve many of the challenges that you have right now. So what we're looking is to collaborate, to put these people to work together with your engineers, to work together with your team, so to address these particular challenges. We understand that access to data is somehow complicated, or our regulation, also critical infrastructure data, which is the electricity infrastructure, is difficult. So what we try to do is to come up with a set of data governance that allow us to work together, develop the algorithms, develop the skills for the people that develop these algorithms, but maybe in your company. So the data doesn't have to come to us, but we bring the people to you. And this is the way that we win together by creating new knowledge and making the tools available for you.
Fantastic, thank you. So I think we've got about 10 minutes left. If there's any questions in the audience, we would love to take them. Yes, I can see there's someone here. I don't know if there are microphones. So perhaps just stand up and shout loudly. Thank you. So I'll just repeat the question for everyone who might not have heard. There were two questions. First question was, are we developing a data taxonomy for different types of data as the data sets get bigger? And the second question was around frameworks for trust of the data, or how can users of the data trust it? So does anyone like to take the first or second question? Sebastien?
Well, maybe I will have two very frustrating but basic answers. So first about the taxonomy. We took it the other way around. So because initially, yes, it was what's the taxonomy and what would be the ultimate goal, etc. First, let's have everything on the table, and then we'll sort out and define the taxonomy from that experience. And if there are places that or areas that domains people don't want to explore, no need for a taxonomy there. But if people want to really address this or that specific matter, then we need, yes, to quickly arrange it. And that's the goal of Digit, to really keep track of the needs and to try to sort things properly so that people would find their way easily in the place. And about the second part, yes, I'm very glad that you pointed out that's our very issue. Before jumping on data and using it, yes, check it. And so that's, as I said, the role of the challenge we will have on this first data set, so that we could have possibly the list of all the checklist of all the problems, and possibly also the solution provided. You have to check that. You have to note where are the holes, and that's here. Looks like a hole, but it's not a hole. It's and everything. So that's we don't have a solution for that, but would like at least to raise awareness about this, because yes, the rest is just to jump and play and get fooled with what you're playing with. So we're not yet there because it's of course very, very wide, but at least as far as this backbone data are concerned, would like to at least have kind of a methodology that we would like to come up with in 2-3 year time, hopefully.
So I will talk about some activities we have in the GridFM community. So in the data kit, we have some measure of data diversity. So that's more an ML kind of matrix. But I think there is certainly more work to be done to further develop more data quality metrics. Then we're also starting cybersecurity track. So the starting point is to say that because of higher inference capabilities of AI models, it's creating a new risk to uncover, to recover some confidential information about a specific network. Also, a specific model could leak information. So here I'm talking about what can you extract from the model. But the question you are asking, it's about data poisoning. And this is very valid. And so far, we have nothing. We have nothing to address this problem, actually. And it's certainly something to look into. I believe for now, the initiatives are still small enough in a reduced circle of people. So it's based on trust. But as you scale, then certainly the issue will be more pressing, let's say. And for data poisoning, I guess it's the question of where is the data stored? What kind of cybersecurity measures are taken to protect the data vault, let's say, to prevent unauthorized access. And so basically, you're talking about an attack on the open source supply chain. So yes, more work is needed along this line, it's true. Actually, at Hydro-Québec, we are using some commercial solution to scan some AI models before using them. We don't have the right to directly download AI models. So we use commercial solutions to scan models, Python packages, and but I guess there will be more to come in the future for sure.
I would just add for Faraday, the model that we've developed at Centre for Net Zero, we've worked with researchers at MIT and Georgia Tech to develop this framework to have metrics for testing the privacy of the data outputs, the fidelity and the utility, and have conducted active attacks on the outputs of the data to check that there is no data leakage. So we're fairly confident that the evaluation framework we've developed for our model works. But as you say, you add more models, perhaps different use cases. The utility of the data from one model output may not fit for a different application. And so that's where we'd definitely look to the community to test those evaluation frameworks and say, do they actually scale across different use cases? And that's where we need your guys' input. Any other questions from the audience? I think we've probably got time for one more. Yes? Front? Yeah.
Thanks a lot. So I have two questions. One on the boundaries of data modeling, and second on the granularity of the use case you want to deploy. So on the boundaries, correct me if I'm wrong, I'm having the feeling your modeling of low consumption data is largely based on smart metering data. Are your models only looking at the smart metering data, or you're trying to get in weather data, political data, data that will impact the behavior of people or factory or buildings? On granularity, I think Sebastien mentioned the data interval is 5 minutes. Are you actually just focusing at 5-minute info data, or you're trying to aggregate also to a higher level, or even find 1 minute, sub-minute interval fluctuations? Even that would be interesting for low voltage, for example. So those are the questions I have. Thanks.
Thank you. Yeah, Pedro, would you like to take the first question?
Yes, yeah, really interesting question. So this is what I meant by multimodality of the data, right? And so far we have focused only on active power, right? Only on smart meter data for the first, let's say, case within the OpenSynth project. But now with this expanding the scope of the OpenSynth project, working together with the GreenFM project, then for sure we need to adapt the models for these different type of sources of data. For your second question related to the time resolution, this was something that we also discussed within the development, thinking of having this foundational concept behind these models requires that we are general enough, right, for dealing with different time resolution data. And of course, we in the OpenSynth, we focus on providing the data for many multiple applications and projects. So this implies that many time resolutions are needed, right? So at least in the particular case of Energy Diff, which is the model that we developed and tested together with Aleander, we handle this. So we develop AI and machine learning, let's say, capabilities for using the same model for handling all these different type resolutions of data. And of course, this saves resources and time.
I'd also add on your first question, I guess with Faraday, we're implicitly capturing consumer behavior by looking at smart meter data what some of the attributes that you can filter for as you're developing your outputs include things like whether a customer has different types of low carbon technologies in the home, or whether they're on a smart tariff or otherwise dumb tariff. And that will capture different behavioral dynamics of consumers in those homes. So I'd say we're currently implicitly capturing consumer behavior, but our goal is to perhaps more directly try and capture how different consumers in different households, in different regions, different parts of the world consume electricity, because we know that they will vary by those different characteristics. Did you want to touch on the second question, Sebastien?
Yes, on the second question, so there are two directions you were pointing at. For going to the smaller granularity, so lower than 5 minutes, I would like to continue conversation with you to understand your use case. Because for me, yes, 5 minutes is already quite detailed, and you have this kind of steady state of the, so that market players can actually address. If you go to a lower time scale, for me, it's the dynamics of, yes, protection activation, such things which are, well, very local, very specific, and and I don't see the need for the rest of the grid. But we can discuss that. And on the other hand, yeah, the 5 minutes, so you have the details, but you're just drawn in it. The idea would be to have, as I said, a higher perspective on the things and to have a better understanding of what are the, how you can characterize the situations and how you can also optimize the topology, because maybe it was not optimal, and what could be the risk, etc. So the idea is definitely to find this kind of global patterns around it. So probably, yes, reducing the time scale, but we don't know exactly how we can do that. And that's also a nice challenge that we can propose.
Fantastic, thank you. Well, I think we're pretty much bang on time. So thank you everyone for listening and for your questions as well. Just a quick reminder of where you can find OpenSynth if you're interested in using the data or algorithms or contributing as well. You can find us on the Linux Foundation website, also on GitHub and Hugging Face. We've also got a Slack channel if you'd like to join for updates. Keep your ears open for the 2026 challenge from Cresym on grid topology data, and we hope to hear more from you throughout the rest of the day. Thanks very much.